All right, we were picking up where we left off with number 11. If you want to watch numbers 1 and 10, see the other movie. And I've never seen these questions before, so let's see if I even get them right. We will go over all the answers at the end. The equation above can be represented by a parabola in the xy plane. The parabola is then translated so that the vertex is at 0, 0. Which of the following best describes the translation? So we need to be able to know the vertex of the current parabola. And luckily, it's written in vertex form. You need to memorize this. This is absolutely just like a memorization question. This is giving us that the vertex is -5, -8. Okay, so how do we get from -5 to 0? Well, that's up. We go up 5, and then we go from -8. I mean, if you need a graph, draw a little graph, right? We're at -5, -8. That's down here. -5, -8. And then we go to 0, 0. So we're going up 5. Ooh, sorry. Ooh, boy. We're going to the right 5 and up 8. See, this is why you draw it out. You got to make sure. So we're going to the right 5. Let me fix that. We are going right 5 and then up 8. Okay. So let's see how they describe it. 5 units in the negative x direction. No. And 8 units in the negative y. Now we're going up. 5 units in the negative x direction. No. 5 units in the positive x direction, yeah. And then 8 units in the negative y, no, it's got to be D. 5 units in the positive x direction, 8 units in the positive y, right? To the right and up, right? So the key piece here is being able to read this and knowing that the vertex formula tells us that this vertex is at -5. That part of the equation flips. They love asking about vertex on the SAT, so you need to memorize this formula so you can be able to read it. And there are other ways of finding the vertex if this doesn't work, depending on other ways that they give you parabolas. So we'll see if we get to those. Cool. Which of the following statements is true about the equation above? Okay, before I read the equation, let's see. One solution, infinite, no solutions. Okay, so this is code that we are talking about lines that have similar slopes. Okay, so we care about the slopes of lines. These are definitely lines because there's no x squared. So in my brain, I'm like, okay, I need to think of this, even though it's one equation, I need to think of it as 2 lines. Because that's, when we talk about one solution, infinitely many, we're talking about things like parallel lines or lines that overlap completely, that are the same line. And so it's easier for my brain to think of the solutions of linear equations, linear systems, as having to do with like a graph. So for me, it's easier to just be like, okay, let's simplify the left side. That's 5x plus 3x is 8x minus 2. And I can put a little y equals in front of that to really see it in y equals mx plus b form. On the right side, I'd distribute this out. That's 3x plus 12 plus 5x minus 10. So combine like terms. 3x and 5x is 8x. 12 and 10, or 12 minus 10, is plus 2. So this is y equals 8x plus 2. So they have the same slope. That's important. They have different y-intercepts. So this is a situation, same slope, different y-intercept. These two lines are parallel, right? They go in the same direction, kind of like this. And so what that means for me is they're going to have no solution. If parallel lines are going in the same direction, they can never cross. They never bend towards each other. So now I'm looking for something that says no solution. So the equation has one solution? Nope. The equation has one solution? Nope. The equation has an infinite number of solutions? Nope. The equation has no solution because the equation is not true. So I'm assuming I did everything right, and it's going to be D. Of course, I could be wrong. It's possible I made some careless mistake. If I had more time, I'd probably come back to this one because it's phrased so weirdly and there's a lot going on. But it's really just a vocab question at the end of the day. It's kind of backwards, but it's testing vocab. Yeah. All right. Yes, another parabola. The graph of the function f defined by that is shown. The graph passes through the points negative 10a and ab, where a and b are constants. What is the value of b? Okay, well, I mean, without really thinking too hard, this feels like a plug points into equations question. I've got points, I've got an equation, let me just do it, right? So let's take the point that we know most of, and let's plug it in. That's going to mean that a is y, 1/4 times negative 10 plus 4 squared minus 5. Let's see if that helps. 1/4 of Negative 10 plus 4 is negative 6, and squared, that's going to be 1/4 of 36 minus 5. So that's 9 minus 5. So A is 4. But we want B, so there's a nice little trap for you there. So let's just finish the job, right? We plugged at one point in, let's plug the other, and now we know that A is 4, so we're trying to find B. Let's do it over here. So B is my new Y, and 1/4 of 4 plus 4 squared minus 5. 1/4 of 8 squared, so that's 1/4 of 64. 1/4 of 64 is what, 16? Yep, 16 minus 5, so B is 11. Feels pretty good. I wouldn't second guess it. I don't think I made an arithmetic mistake. I would move on, and that's the beauty of plug points into equations. This looks like it's going to be very complicated. I didn't really think about it at all. I just dove in, plug points into equations. It's really the best strategy because you don't have to think very hard. Okay, which of the following is a solution to the given equation? This is very clearly going to be a quadratic formula question. If you do not know quadratic formula, if you are not good at algebra, skip this, okay? It's gonna be a pain, and there's really no shortcut here. You're just gonna have to know the steps and know the steps of the order of operations very, very well. So remember how we do quadratic formula? We have our A, our B, and our C come from the equation when it's in this form. This is equals 0 form. And so negative B, so negative 12 plus or minus the square root of B squared minus 4AC all over 2A. So I'm going to start simplifying. That's 12 plus or minus the square root of 144. 4 times 23, times 4. 3 times 4 is 12. 4 times 2 is 8, 9. Okay, over 2. Okay, 144 minus 92. 2 from 4 is 2. 9 from 14 is 5. Ugh, really? Is that right? Yeah, that's right. 12 plus or minus the square root of 52 over 2. So you got to know how to reduce radicals. This is why these are so hard. So 52, I know from a deck of cards, is 4 times 13. And 4 is 2 times 2. So what we're doing with simplifying radicals is trying to find pairs of numbers, because a pair can come out. So when we have the prime factorization, we know we've got all the little pieces that make up the number of 52, and there's 2 2's, so the 2's come out, and that leaves us with 12 plus or minus 2 root 13, that stays behind, over 2. And finally, notice that 12 and that 2 were hanging out there for a long time, and it's very tempting to reduce them, but we can't do it until the very end. So 12 can be divided by 2, but the 2 also needs to. This is like distribution. So that's going to be 6 plus or minus root 13. And there you go. We just need 1 so as a solution. So yeah. So if we had somehow, I don't even know where you could have gone wrong, somehow in this process you could have gotten an 11. I think the most common mistakes actually are going to be doing something wrong with the 12 and the 6. And honestly, I don't see a clear trap answer, but I think that if you got this wrong, you probably just would have done algebra that you just wouldn't have understood, and you wouldn't know what the right answer is. You would have had something completely different than any of these. And this is why this is a good skip for most people, is it's time consuming, it's tedious, it is very, very prone to mistakes, and hopefully I didn't make any. I may have made some, but yeah, it's not an easy question no matter what. Here, the points negative 310 and 310 are endpoints of the diameter of the circle. So the only time that plug points into equations doesn't work is when we have circle centers. The center of a circle does not plug nicely into the equation, but these are not center points. These are endpoints. These are on the circle itself, so we can plug these in. So just take the 310 and see what happens. So choice A, we'd have 9 plus 10 minus 10 is 0, right? Squared is 9, so that works out. Let's keep going. This would be 3 plus 3 is 6 squared plus 10 squared. and that's not 36. Wow, that's a much bigger number, so that's wrong. This would be 6 squared plus 0 squared, so that's 36, not 9, right? So maybe I should be clear, 9, and that doesn't work, so that's gone. And D would be 6 squared plus 0 squared is 36, so that does work. This is not surprising. We can just take the other point and try that out in A and D. So in A, that would be -3 squared is still 9, plus 10 minus 10 is still 0. So 9 plus 0 is 9. That still works. D, this would be -3 plus 3. That's 0 squared, plus 0 squared is 36. Nope. So it's got to be A. And there are ways to get this by understanding the circle in another way. You can kind of draw it maybe and say, okay, I've got a circle with endpoints at -3, 10, that's up here, and +3, 10. And so the center kind of has to be right in between, which is the point 0, 10. And the way the circle equation works, it's x minus h squared plus y minus k squared equals r squared. Well, the x coordinate of the center is 0, so that will just reduce to x squared. The y coordinate is 10, so that is just y minus 10 squared, which is what we have. And then the radius is 3, because that's the distance from the 0 to the 3's, and so squaring 3 gets us 9. So it makes sense, and that's probably a faster way to do it if you are really confident with the circle equation. But I think the point I'm trying to make is even if you're not confident with this memorization stuff, these strategies can save you points. Let's do 16. And this is a good example where now if you are also running out of time, you should have skipped a bunch of those ones we just did because this is where the questions get easy again. And so you want to pick up these points as quickly as possible and, pad your score a little bit. Don't run out of time. So the solution to the given system of equations is x, y. What is the value of x? So we're just going to solve this the old-fashioned way. Yeah. Well, my instinct on these is to do elimination. But you might be able to do a little bit of, substitution if you want. Let's do elimination. Let's do substitution. Let's do it. So I'm going to rearrange this to x is equal to 2y plus 8. It's very easy to add that 2y to both sides. So now I'm going to substitute that in here. So that's 2 times 2y plus 8 plus 3y is 2. So that's 4y plus 16 plus 3y is 2. So that's 7y minus the 16 is -14, and y is -2. But I want x, so we just take any equation and plug it back in. We can plug it in right here so that x is equal to 2 times -2 plus 8. So x is equal to -4 plus 8. X is equal to 4. So hopefully I didn't make any careless mistakes because point of intersection questions are very prone to error. Lots of steps, lots of negatives and things flying around. It's very easy to make a mistake. So if I had more time, I'd come back, but let's move on and see if I made any errors at the end. What is the value of n that satisfies this equation? Okay, well, so let's subtract 3. Oop, nope. Let's subtract 9n. And we get 3 is equal to 6n. So we divide by 6. And we can reduce 3 over 6 to 1/2. You can bubble as 1/2. You can bubble it as 0.5. But yeah, seems right. That's what I mean. These are easy questions here. Don't leave these behind. The function f is defined by f of x equals 2x plus 10, 2/5 x plus 10. For what value of x does f of x equals 30? So we need to know how to read this function notation. So what they're telling us then is that the y value is 30. So that's going to go in right here. So 30 is equal to 2/5 x plus 10. Let's subtract 10 from both sides. We get that 20 is equal to 2/5 x. And this is a step that not enough people know. If you need to get rid of a fraction, we multiply by the reciprocal on both sides to make it go away. So 5 and 5, 2 and 2. This is why this works, is you're crossing out things that are on the top and the bottom. At the same time, when you're multiplying fractions, you can also reduce those fractions before you multiply them, right? So 20 is 2 times 10. Get rid of those 2's, right? Don't bother reducing. It might make this case it might be easy, but in other cases it might be much harder. So now I have 10 times 5 is 50, and so that should be it. Number 19, an office building has a room with a square-shaped floor. The actual length of the floor is 90 times the length of the floor on a blueprint drawn to scale. The actual area of the floor is P times the area of the floor on the blueprint. What is the value of P? Ooh, okay. So, I've got a blueprint square and a big square. An office building has a room with a square-shaped floor. The actual length of the floor is 90 times the length of the floor on a blueprint. So how about it's 1 and 90? Can I do that? Arithmetize a little bit. Arithmetize. The actual area of the floor is P times the area of the floor in the blueprint. Okay. So I get what's going on here. I get why people are going to make a mistake, though. So obviously 90 is not the answer, right? Like, you should know that we're at number 19. We're in the questions that are supposed to kind of start to get hard again. It's not going to be 90. It's too obvious of an answer. But if we arithmetize, hopefully we can see the correct answer. So if the length of the blueprint is, let's say, 1 foot, I don't know, 1 inch, then the floor is going to be 90 inches, 90 times that. That's what it's saying here. But all of the dimensions would be multiplied by 90, not just the length. So the width, which we can also say is 1, is also going to be 90 times bigger. So it's a 90 by 90 floor. Oh, and it says it's square shaped. So there you go. Even if it's set as a rectangle, it still work the same way. So what is the area of the floor? Well, it's 1 by 1 in the blueprint. And then 90 times 90, that's going to be, I can show you the actual math here. So 0. So 9 times 0 is 0. 9 times 9 is 81. So there it is. The actual area of the floor is P times the area of the floor in the blueprint. So because we chose 1 in our original, it's very easy to see that the difference is 8100. So that's just the answer here. If we had chosen a different value for the length, we still would have gotten 8100. We would have had more steps to kind of reduce, but that's why you choose 1, as it usually works. All right, 20. The graph of this is shown. What is the value of A? Okay, this feels like a plug points into equations, right? I've got a bunch of points, got a bunch of equations. So, okay, or one equation. So let's start with the simplest point. That's usually the way to go, 0, 2. So y is equal to A, or let's actually plug the point in. So 2 is equal to A times 0 squared plus C. So 2 is equal to, this all cancels. So 2 is just C. So that's something, but I want A. So let's pick a new point. Let's try 2, 3. So 3 is equal to A times 2 squared plus 2, right? Because C is 2. So 3 is equal to 4A plus 2. Subtract 2 from both sides. 1 is 4A. And then divide by 4. And we get that A is equal to 1/4. So there's, again, plug points into equations. Works so well. That looks like it's going to be really hard. You just got to trust the process, choose the easiest point, and it should work out. Or at least we hope it works out. Let's take a look at the answers. And as expected, I got everything right. I very, very rarely get a math question wrong. When I took the actual SAT in high school, I got an 800 every time I took a math test. Both the SAT and all the subject tests that existed back then, I very rarely get a math question wrong because I use the strategies and I don't fall for the trap. So I felt that the hardest one, to be honest, this is kind of hard the way it's worded, but it's very easy if you understand the vertex. This is easy if you understand the vocab, but I get why that could be hard for some people. This is a must get for everyone. This is just plug points into equations. This is a very tough question here. And then, strangely, this one also is a kind of a must get. You have the ability to just plug those points in, so you can earn this even if you know nothing about circles. You're just doing a bunch of arithmetic. In this grouping here, especially if you are the kind of person who runs out of time, they were definitely easy points. I would say number 17 and number 18 especially are easy. And surprisingly, number 20 is pretty easy because the strategy makes it easy. It's, for most people, it's a hard question, but if you're thinking strategically, it becomes just a matter of robotically plugging the points in and solving for the missing letters. That's algebra, right? So this is the power of plug points into equations. It really works, and I hope you noticed that as I was going through these, that was usually the easiest strategy for me to recognize. If I saw equations, if I saw points, I plugged the points in the equations. I didn't bother to worry about whether it would work. I trusted it, and it got me the points.